Now, as you all know about electromagnetic wave theory, so there are certain limitations, or you can say there are certain phenomena which could not explain the behavior of the light, or you can say the radiation on the basis of electromagnetic wave theory. So we are going to see that what are those phenomena actually which are not being explained on the basis of electromagnetic wave theory. So first is that it could not explain black body radiation, right? It could not explain photoelectric effect. It could not explain that why different solids have different thermal capacity, and moreover they fail to explain line spectra of atoms. So what we are going to do is now we are going to study each phenomena in detail, that what actually is the black body radiation, what is the photoelectric effect, or what is the line spectra, and what are the, you can say, what are the main features which could not be explained by an electromagnetic wave theory, considering the that we consider that light is a wave and it believes in a continuous generation of energy. So we are going to see that. So first we are starting with the black body radiation, right? See, suppose you have any material, and particularly a material which has a high melting point. Let's say iron bar. Let's take an iron bar. So suppose we have an iron bar whose melting point you already know that is very high. So what happens when you heat it? We see that it changes its color, right? Like when you heat it first, when you heat it to a very high temperature, it becomes first red. Then you increase more temperature, it becomes yellow. You increase more temperature, it becomes white, and at very high temperature it turns blue. So this is this thing is actually seen that whenever any object with the high melting point is heated. So what do you actually like by studying this? What we actually learn about it? We have learned that there is a change in color with change in the temperature. As more and more temperature is increased, we see that there is decrease in wavelength. As you all know that red has a higher wavelength and this has a lower wavelength. So that means wavelength is continuously decreasing as you are increasing the temperature. Now, why it is called black body radiation? As you know that the black body is the perfect emitter and the absorber of radiation. Black body is the perfect emitter and absorber of the radiation. So whenever the radiations, or you can say the radiations which are emitted by this perfect emitter and absorber body, that is the black body, the radiation is called as black body radiations. So we see that the energy which is emitted by a black body, or you can say that black body radiation contain an energy, and on what factor that energy depends? That energy depends upon the intensity, and we know that intensity depends upon square of amplitude. Just for your more information, I'll just brief it again, that what is intensity? Intensity is that how much radiation is traveling 1 meter square area in 1 second. How many radiations are traveling 1 meter square area in 1 second? It depends upon amplitude. Amplitude, I think you got it, that it is maximum displacement of particle about its mean position, either in lower or upper direction. So we say that with that whenever a body is heated, or whenever black body is heated, we see that there are particularly change in the color that occur, and that means the color is changing. So if we talk about the energy emitted through a radiation, then the energy depend upon the intensity, which in turn depend upon the square of the amplitude. So this we have seen. So as the energy depend upon intensity, so that means when you are continuing heating any object, so then the intensity might change. The energy is changing, that means the intensity might change, but the frequency should not change. The frequency should remain the same. But if you means, this is according to the electromagnetic wave theory. Again, see, according to the electromagnetic wave theory, if you apply electromagnetic wave theory to this black body radiation phenomena, we see that the energy emitted can be more or less. That means, because electromagnetic wave theory believes in continuous generation, you know that. So here the energy emitted depend upon the intensity. So that means intensity can be more, intensity can be less, just depending upon the amplitude. But it is independent of the frequency. So whenever such body is heated, there should not be any change in color which should take place according to electromagnetic wave theory, but the intensity might increase or decrease. But here if we apply that theory, we have seen that here the color is changing. Color is changing means frequency is changing, but according to electromagnetic wave theory, the intensity might increase or decrease, but the frequency is going to remain the same. But so this could not be explained by by considering light as a wave or by an electromagnetic wave theory. Got my point? That electromagnetic wave theory says that it believes in continuous generation of energy, right? So if you apply this theory here, then but here what we see that the colors are changing. It is first red, then yellow, then this. So that means there is a break that is occurring, then it switch on to this. So that means it is actually showing that the energy flow is discontinuous, not a continuous one. Because according to electromagnetic wave theory, the intensity might increase or decrease. This may happen according to electromagnetic wave theory, but the color should remain same, the frequency should remain same. But here what we see that colors are changing, that means frequency is changing, because as you are heating, so it is because the radiations are going from high wavelength to low wavelength, or you can say from low frequency to high frequency. As we know, wavelength and frequency is inversely proportional. So that means this could not be explained by electromagnetic wave theory. So there is particularly a new theory which will consider light as a, you can say light not as a wave particularly, something else, we will discuss that, and this phenomena is actually explained by that theory. So till this time what you do is just make yourself familiar with the black body. So if you get a question like this, you need to write that when any body with higher melting point is heated, this color change is observed with increase in temperature. But according to electromagnetic wave theory, there is a continuous generation of energy, right? So that means the energy depends upon the intensity, which in turn depends upon the amplitude. So if we try to explain this on the basis of electromagnetic wave theory, the intensity may increase or decrease, but the frequency should remain the same. But here we see the change in color. That means frequency is changing, wavelength is changing. So that means it could not be explained by electromagnetic wave theory. So this we have done. That I think you know now that what is the black body radiation. Now we are going to see that what actually is the photoelectric effect.